Okay, listen up here. So we collected that sheet from Friday from some of you.
Yeah.
Okay, got it. All right, so we collected it. We got one more section. It's called direct variation. And kind of throws a little bit of a curve at you. We'll take 2 days on this. We'll review for a couple of days, but then we will have the chapter 5 test Friday. I think it's 80 points. And we already had, was the first test was on this 9 weeks, right? That one.
So.
Yeah, it was.
Chapter 4 test.
Yeah, the chapter 4 test. So that was on, because we took it on that Friday and it was on this 9 weeks. So we got that. And like I said, this one here will also be, I think the other one was 80 points. I think this one as well is 80 points. But this is the last, I guess, the new section of the chapter. I think we got everybody. So I did not get attendance. Okay. For that. All right, so take a look. Identify, write, and graph direct variation. It's a form of a linear function, but it just has a special equation. And it's just, a lot of it's just kind of a little bit of a common sense, what you would expect. If you need 2 eggs for a dozen cookies, how many eggs are you going to need for 2 dozen? 4. And how many are you going to need for 3 dozen? It's going to be a direct relationship. That's why it's called direct variation. Okay, if you need 1 cup of sugar for your recipe and you're going to, make it for, that works for 10 people, you're going to make it for 50 people, you need to do 5 cups of sugar. It's a direct relationship. Okay, so the recipe for paella calls for 1 cup of rice to make 5 servings. If you're going to make 2 servings or 5 servings, use 1 cup, 10, you need 2, 15, 3, 20, and 4. Okay, you can create an equation, y equals 5x, describes that relationship. Okay, and so the number of servings varies directly with the number of cups of rice. So it has a direct relationship, direct variation. And this type of equation will represent direct variation. Really, you just have a number in front of the x. Okay, so a direct variation is a special type of linear relationship. So it's going to be a line that can be written in the form y equals kx. So make sure, okay, in that first blank goes direct variation. In that second blank goes constant of variation. That is your k value. That is your k value. All right, some direct variation equations. How about y equals 2x? And you would say k is 2. So big thing is going to be, so what's k? K tells you how the two variables are related. So k is 2. Y equals negative 1/3 x. K is negative 1/3. Y equals 7x. K equals 7. All it can be is a number with the x. Okay, now non-direct variation equations would be, say, y equals x plus 4. If you got a plus or a minus anything, then it's not direct variation. Okay, you cannot add or subtract anything. Y equals negative 2x minus 5 cannot be direct variation. And you cannot have a square. So like if you had y equals 2x squared, not direct variation. You can just have an x. All right, so that's all you have to do is identify and say, all right, this is k. And then you're done. Now, they're not all given to you in this nice of a format. Sorry. Okay, sorry. But can we make them look like that? That's the key. All right. Hold on here for a second. Yeah, I know. And let me do something. Go ahead and take a look at that first one. Okay, that's the rest of them.
So on that first one, do we think we have a direct variation?
Yeah.
Yeah. what would our K value be? Go, Jalen. No, when we're talking about K equals what? K equals 3.
Yeah.
So our K would be 3. So for number 2, what would we have to do in order to be able to easily tell if I have a direct variation? Zach?
You have to subtract 3x from both sides.
All right, I would subtract 3x from both sides. I'm solving for y. Okay, so after I do that, do I have direct variation?
No,
Why not?
because it has a subtraction.
We're gonna add 8 onto whatever we're gonna multiply, so that would not be a direct variation.
Yep, you can just have the x part. And so you got a plus or minus anything, not direct variation. So anytime you see direct variation, you want to think y equals kx. First one is written like nicely. You just say k is 3. Yes, it is direct variation. But in this case, just say not direct variation. Not direct variation. So like the two quantities aren't directly related. All right, that third one, or write down the third one, which is, whoops, hold on. There it is. You have it written down?
Yeah, just 1 second.
Okay. All right, that third one. Now this one here, it's easy to make mistakes on this one. Again, like Mr. Schler said, you cannot say yes or no until you get y by itself. Okay, you might think it's one thing, but you can't be guaranteed until you get like y equals something. So we got to do that by adding 4x here, adding 4x here. All right, when I do that, what should I write? Zach, what should I write underneath there?
3y equals 4x.
3y equals 4x. You don't need to put 0 plus 4x because that's just going to equal 4x. So 3y equals 4x. Jay Lee, what do you think I do now? I got to get y by itself. What's with the y? 3. Is it multiplying the y or dividing the y? Well,
No, oh wait.
it's multiplying. So what do I do? What's the inverse of that?
Dividing.
Divide. So divide by 3. Divide by 3. Now, if you divide and you pulled your calculator out and you said 4 divided by 3, what does it tell you? George?
1.33.
It says 1.3 repeating. Don't mess with decimals. Leave it, go ahead and just leave it as a fraction. So what would that look like as a fraction? You would just say y equals 4/3 with the x beside it. You can do that. You can move the x to the side. All right, Joe, is that direct variation? You don't even know? Okay, let me go back for a second. Let's use our resources. All of these are direct variation equations. What? Why not?
I don't know.
Okay. All you're looking for to show direct variation is it just a number times x? Can you simplify it to a number times x? And for this one here, is it just a number times x? So yes, it is. You just have that 4/3 in front of the x. You don't have a plus or minus anything. You don't have any exponents. So yes, it is direct variation, and your k value is 4/3. Okay. So it is direct variation. K equals 4/3. All right, now this fourth one. Oh man, that's too easy.
That's hard.
Sorry.
You can use it.
Okay, y equals negative 10x. This is y by itself. Yeah, is it a number times x? Yeah, direct variation. K equals negative 10. So nothing to do. Nothing to do. Direct variation. Variation. K equals negative 10. K equals negative 10. All right, if you think you can figure this out, go ahead. If not, then wait. We'll go in together. 6x minus 3y equals 0. variation? We got Final answer.
Y equals 2x.
good. Y equals 2x because I'm going to subtract 6x. Good. And you get negative 3y. And that's just going to be negative 6x. Now divide by negative 3. And so you get y equals 2x. Yes, it is direct variation. And for this case, k equals 2. So you gotta watch, you can't just say yes or no right away until you get y by itself. You just do I have a number times x. If you're adding or subtracting anything, it's gonna be no. Get any exponent, it's gonna be no. For that one. All right, so take a look. What happens if you solve, when we've done this, y equals kx for k? This isn't on there, so just pay attention to this. All right, how do I get k by itself? What's the only thing I need to do? Preston, what do you think? I got this right here, y equals kx. If I want to get x by itself, or excuse me, k by itself, I lied. If I wanted to get k by itself, what would I do? Divide by x. So I would take y equals kx, divide by x. So that means k is the same as y over x. Now you got that grid right there on your paper, right? So if here's what happens when you're given a table. If you got y equals 2x, I know that's direct variation. If you take the y coordinate divided by the x coordinate, 2 divided by 1, I get 2. If I take 4 divided by 2, I get 2. If I take 6 divided by 3, I get 2. You see a pattern? Okay, the number I got in each case is going to be 2. That's how direct variation is going to work. All right, now you don't have this grid on your paper, but just pay attention. You got y equals negative 5x, right? If you plug in x is 2, you get back negative 10. Negative 5 times 4 is negative 20. Negative 5 times 6 is negative 30. But if you divide y by x, negative 10 divided by 2 is negative 5. Negative 20 divided by 4 is negative 5. Negative 30 divided by 6 is negative 5. Okay? That pattern is always going to happen. That pattern is always going to happen. Now, if you're given the table, flip it over in the back. Okay, it says tell whether the relationship is direct variation. You have it like this. It might help you if you want to write it 2, 4. Vertically, you don't have to. But if you want to tell whether it's direct variation, here's what you do. You check. You check y divided by x. Okay? And what do we want to see? Any ideas what do we want to see what's going to happen? Preston?
For it equal the same number.
Yes, we want it to equal the same number. If it equals the same number, it is direct variation. Okay, because we just showed over here. Okay, we kind of used something we already knew was true. But now we're going to go to something we're checking and say, all right, we want to check it. So here's what I need you to see. Show me. Show me y divided by x for each one. 6 divided by 2 is 3. Write that right next to it. Okay. And then write 12 divided by 4 is 3. And then write 18 divided by 6 is 3.
The explanation part here is important because if you do x divided by y, you'll still have the same answer. Everything will be 1/3 or 0.333. But you could say, yes, you do have a direct variation, but your explanation would be wrong because the k value here is 3, not 0.33 or 1/3. So you have to keep those variables straight. It's always y over x.
And we do need to find, like you said, that k value. So is it a direct variation? Yes. Direct variation. since y divided by x equals 3 for each pair. Now, what, even though it doesn't ask me, what does k equal in this case? You're gonna be asked to determine that. Okay. What is the value of k? Christian?
Is that for the first one?
Yes.
3.
3. K is 3. It's whatever you get when you divide all of those values. So like Mr. Server said, you divide backwards, you're gonna say it's 1/3 would be correct in this case. All right, so you check to see whether they're all the same in a table. I got another table. Now this one's given to you vertically. You want to test it to see whether it is direct variation. So now, I just like to, let me just move it over here. Grant, tell me what order to divide for these. And tell me what those numbers are for the first one. What's that give me? Gives you what? Oh man, I'm gonna say no. So I'm gonna say no. You're dividing 0 by a number. That's always equal to 0. Yes. So that is 0. What do you divide for the second one? 3. And what does that equal? 3. And how about the next one? Which equals what? Okay, now don't convince yourself it's 3, because if it's 3, then it's going to work out right. Make sure you do the actual math. You do 0 divided by -3, and then that's 0. So are they the same number? No. So this is not direct variation. Not direct variation. Since y divided by x is not a constant. Okay, since it's not a constant. Okay. So that's what you're looking for in a table. If you're just given an equation, which I think is a little bit easier, that's me. If you're given an equation, you get y by itself, and then you test it. Is it just a number times the x? If it's plus or minus anything, it's not. If you're given a table, you have to divide. And you got to show me those values. All right, the next type, kind of the last type here. Read through that if you would. Read through that. All right, it's gonna probably look like a bunch of jibber jabber first time through.
These ones that struggle with fun tests.
Yes.
Freaks you out.
The value, all right, this first statement tells me something. It says the value of y varies directly with x. It already tells me that's true. That means that y equals kx can be used. I know that's going to be true. I just need to figure out what k is. That's part of it. And they give me some information. They tell you y is 3 when x equals 9. What you want to do, the very first thing you want to do is you want to find k.
And you are ignoring this last part. But you gotta do 2 steps here
So
before you
yeah.
even get to that last piece.
So don't, I'm even gonna cover it up. So. Okay, we're gonna ignore it. You can't even see it. All right, so the value of y varies directly with x. So that means y equals kx comes into play. And y equals 3 when x equals 9. So what I can do is I can find k by plugging in those values. So y is 3, x is 9. So k times 9. I want to solve for k, so what do I need to divide by? Divide by the 9. Am I right, Colin? All right, now when you divide by 9, if it gives you, and I can write k equals, it doesn't matter, that's okay. K equals 3/9. It's going to give you a decimal. I don't want to use a rounded off decimal, so you're going to have to just reduce that. What is 3/9 reduced to? Okay. Great.
1/3.
It's going to reduce to 1/3. So keep it as 1/3.
And here, what we have, again, just like we were doing with the tables, it ends up being y divided by x.
Yep, good point. Now, give me the new equation. So you can take the k, so y equals kx, you can write it as y equals 1/3 times x, because k is now 1/3. And I'm going to use that from here on out. So write y equals 1/3 x. Now, let's take a look at that last piece. Find y when x is 21. Well, what's the only thing I need to do?
Plug in the 21.
Plug in the 21. So if you do this bit by bit, I think it's a little bit easier. I think that's a good idea. Is just ignore that last statement till the very end. So you got y equals 1/3 times 21, which is 7. So that's going to be, in the end, your final answer. But I am going to ask you, say, fine, give me k. Give me your k equation. So this is k. Right here, this is my equation. And then there's your final answer.
Is that how it's written on the test? Or
Yeah, because it's telling us find
what's
k.
What's the equation?
What's the equation? And then I forget how it's worded, final answer or for that one. All right, so let me do that for this next one. Read through this. So I want you to figure out what k equals, what your equation is, and then what y equals when we're done. All right, if you think you can work through there, go ahead. If you're not quite sure, just wait. Yeah, that's your equation, so I need that. So I need to know k, and I know you can look at k, no k, so I can add, you give me what k is, and then you also have to okay. Okay, now divide by. Very good, good. You may multiply. So what I do, I want to do the k by itself. So y is kx. Now, they tell you y is 4.5 and x is 0.5. Use that to find k. So plug in 4.5 plus 0.5. Yeah, now how do you do solve for k?
Divide those by.
Yes, do that, do that. You got it? There you go.
So this is kind of easy.
Okay. All right, so you got it. You got everything? Perfect. All right, good. Josh, you good? Okay. Okay, now for your equation, what you want to do is you want to make this y.
Oh, never mind.
Take on k.
I was just like, what the heck?
Use that equation to find your x. Okay. Good. All right, good. All right, excellent, excellent. Okay, now when you're doing this, you use that first piece of information, since it says y varies directly with x, we know we can use this form. And so we use that first piece, y is 4.5 when x is 0.5. So it's probably not as easy to figure out because we're dealing with decimals, but they end up working out to be nice numbers. So if I divide by 0.5, you get 9 equals k, or k equals 9. So that's the first thing, k equals 9. Your equation needs to be using this y equals kx with the new k value in it. So write it as y equals 9x. Now, we use that to answer this last little statement. It says find y when x is 10. Well, if y equals 9x, then I plug in 10 for x, and I get 90. So that last one is going to be 90. So k is 9. Your equation is y equals 9x. What's that? It's not too bad once you get it down. And then y equals 90. Okay, for that one. All right, we got a little bit of time, and so while me and Mr. Schler are here, let's see, get as much done as you can. What's that? Yeah, it's not too bad, and then we can give you a little bit of help. Try to keep it a little bit lighter. Happy Monday.
Can we do another day on this tomorrow?
Yeah.
Drafting them?
Yeah, I gotta show you something, get a quick opinion. Let me turn this off on shirts.